Okay, 55 is similar to 49 and 51, but there is a difference, and that is the fact that one of the forces, one of the components of force, here the x component of force, is not a constant. So we can't just say force times distance. We have to integrate the force as a function of distance. So this is the equation from chapter 7 on page, let me just check here. It's on page 153. Okay, this is equation 736, and I just wanted to explain how to use it here because this is, in this problem, we use this equation. Okay, so the work is the sum of all the works done by each component of force as you move from the initial position to the final position. So the way we can write that is write it separately for the x, the y, and the z. So I integrate the force in the x with respect to x. I integrate the force in the y with respect to y, and likewise for the z. And I apply my limits of integration, which is the displacement in the x, the displacement in the y, and the displacement in the z. In other words, the displacement in the x is moving from position x initial to position x final. So in this case, we only have forces in the x and the y, so we won't be using this term because there is no force in the z. But if there was a force in the z, we would just do it a third time. So here's my initial position, 2x, 3y, and from that position I move to a new position of negative 4x in the x and negative 3 in the y. So I'm going to integrate 2x. That's my force, 2x. So the integral of 2x with respect to x, the 2 is a constant. It pulls outside the integral, and the integral of x is x squared over 2. Over here, the 3 pulls out of the integral sign, and the integral of dy is just y. So my limits of integration for x are from 2 to negative 4, and in the y from 3 to negative 3. So as you know, you take the final position, you plug it in, and then you subtract from that what you get when you plug in the initial position. So the 2's here, you can see, cancel out, and I'm just left with x squared. So negative 4 squared minus 2 squared. And then on the y side, plug in negative 3, and then subtract from that what I get when I plug in 3. So there's the numbers when you do the math, and when you add all those up, you get your final answer of negative 6 joules of work is done.